Hello. Today we are going to solve examples where we will write the sum as a product. To do this, we're going to use putting the common multiplier outside the brackets, or, as they say in math, we're going to break down the sum into multiples. What do we need to do this? Let's write down the following example. 3ab's plus 9ac plus 27ad. In order to write the sum as a product, we need to isolate the common multiplier. What do we do to do this? The first summand contains the multipliers 3 and the letter multipliers a and b. The second summand contains the number 9 and the letter multipliers ac. And the third summand contains the number 27 and the letter multipliers a and d. We can already see that the common factor is a letter expression. The alphabetic expression, it's a. So I can take this multiplier out of the parentheses. But notice that 3, 9 and 27 can be divided by the number 3. And then we'll rewrite this expression in a different form. 3ab's, that's what I'm going to write down, 3ab's plus. But 9 can be divided by 3. And then the result of 9, I can write it down as 3 times 3. I'm rewriting the letter part, plus the number 27, also divisible by 3. And then 27 is 3 times 9. The letter part is rewritten AD. And in this case, I see that I have the same next part. 3a's. And in the second summand, I can see 3a. And in the third summand, I can see 3 and a. As a result, I can take these multipliers out of the bracket. 3a's. What's left in the parentheses? If I took away the 3a's from the first summand, I'm left with multiplier b. I write it down, plus. In the second summand, I take away 3a's. What do I have left? 3c's. Then I write down 3c's. And in the third summand, I'm left with 9d's. And as a result, I've written the sum as the product of two multipliers. The next example we're going to solve. It looks like this. 0.75 AT plus 3/4 AB minus 9/16 of A. If there are fractional numbers in the example expression, we can also consider them as a multiplier. What can we observe? The first summand is 0.75. But I can write this decimal fraction as an ordinary fractional number. And the 75/100, I will write it down as a fractional number, 75/100 of an 80 plus 3/4 of B and minus 9/16 A. Let's continue. To multiply these summands by a multiplier, but the fraction 75/100, we can divide the numerator and denominator by the number 25. And then the result is 75 divided by 25 is 3, and 100 divided by 25 is 4. And we can see that we get the fraction 3/4 AT. The second summand also contains the fractional number 3/4. The letter part, AB, and the third summand is the fraction 9/16. But let's check it out. If the first two summands have the same fractional part, then let's try to divide 9/16 by 3/4. And indeed, we can write 9/16 as 3/4 times 3/4. And I'm going to rewrite the letter A. What do we get as a result? Notice that we again see the common multiplier, which is 3/4 A. Let's check if this multiplier is contained in the second summand. Yes, 3/4 A. And in the third summand, we also have this multiplier. So we can write this multiplier in front of the parenthesis. And then what's left in the parenthesis? We've taken 3/4 of A. We're left with T. The second summand remains B. And the third summand remains 3/4. We've done the decomposition into multiples. And one more example, where I'm going to write down a squared b minus ab squared and plus ac squared. We can see that this expression contains only the letter part. Of course, each summand has a coefficient that equals 1. But we're not going to write down the quotient, but focus on the letter part. The point is that a squared b, I can write it down as squared. I can write as a times a in b rewrite. In the second summand, I can write a times b and multiply it by b again. So I tried to write b as a multiplier and plus ac multiplied by c. Now let's pay attention to the same multiplier. We can see the first summand has a, the second summand has a, and the third summand has a. There are no more identical multipliers. Even though there is b in the first summand and there is b in the second summand, but in the third summand this letter part is not present. Therefore, we take out the common multiplier and the common multiplier is a. And then we end up with a multiplied. That leaves ab in the first summand minus in the second summand b times b, which is b squared, and plus c squared. As a result, we have also decomposed this expression into a multiplier. But to avoid writing the degree as the product of several multipliers, let's take note of the fact that in our summands, we have taken out the common multiplier, which is equal to a. I want to draw your attention to the fact that in the first summand a in the second degree, in the second summand a to the first degree, and in the third summand a to the first degree. And the parenthesis we put behind the bracket, just a to the first power. So if you're working with expressions that contain degrees, then we put the lowest degree expression, an expression of the lowest degree. And in the square of a and a, the smallest degree is equal to 1. Therefore, we can immediately put the smallest degree behind the bracket. Next lesson, we will solve another example. And today our lesson has come to an end. Goodbye. See you again.